question is, a game involves rolling 2 dice. Player A wins if the throw totals 5, 7, or 9. Player B wins if any other total is thrown. What player has the advantage? Explain.
Okay, so we just have to. So we have to find out. We have to find out if probability. We have to compare probability of A winning versus probability of B winning, right? Now, how many dice are rolled? Is it 1, 2?
2 dice.
2 dice.
2 dice or 2 dice.
English is stupid. Okay, so it's 2 dice. It's dumb. Okay, so let's calculate PA winning. So apparently there are 1, 2, 3 sums. Okay, let's talk about the number of ways you can achieve a sum of 5. You know, one nice trick you can do with these dice questions is you can actually write down a little table for a pair of dice. So maybe you can go like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 for the second die. You can do sums. So you're adding 1 to each of these numbers.
But you have to write 36 numbers.
Huh?
You have to write 36 numbers.
Yeah, the 36 numbers.
So just double check what I did here. So if you add 1 to 1, you get 2, 1 to 2, you get 3, and so on and so forth. 2, 3, 4, 5, 6, 7. So then each sequence, you're adding 1 more to these than you did up there. So if this starts at 2 and ends at 7, this starts at 3, ends at 8, 4, 9, 5, 10, 6, 11, 7, 12. So how many ways can you achieve a sum of 5? Well, you can see that to achieve, so let's do squares for A. So to achieve a sum of 5, there's a 5. And how did you get it? 1, 4. But of course, you'll notice this one, 4, 1. Are those 2 different physically possible outcomes?
Yeah.
Yeah, this is, if this is die 1, this is die 1 is 4, die 2 is sorry, this is die, this die is a 1 and that die is a 4 versus the inverse of that, right? But you notice, okay, anyhow. So that's a 5. That's a 5. And that's a 5, right? See them running down there.
4.
And I don't think there are any others, right? So yeah, so there are 4 ways of getting a 5. Now let's talk about 7. See any 7s up there? Yeah. They all are down here. And what's the other one?
One more. 6. 6. Right at the bottom. Right at the bottom.
And do we have any 9s?
Yes.
Okay, so you've got 3.
14.
You've got 4 5s. And you have 6 7.
Plus 4.
4 9s. And what you have to divide that by the universal of possibility, which is all of these outcomes, which is 36.
36.
So we have 10 and 4, which is 14. Cut in half is 7 over 18, and that's it. Now, you have to calculate P. B wins. Well, the nice thing about this is, in terms of winners, this is binomial. If A doesn't win, who's winning?
B.
So B is really the B is the opposite of A, isn't it?
Yeah.
So sorry, like that, right? So this, so since, okay, so 50%, right? The 50% barrier would be a 9, right?
Yeah.
So A's probability is less than half, right? So what does that mean? B's probability has to be more than half, right? So you can say that that's going to simply be 18 less 7 over 18, right? Which is going to be 11 over 18, right? Which is greater than probability of A winning. Therefore, what was the question? Who has the better chance of winning?
B.
Therefore, B has the
Better chance.
ad.
Sir, when you're doing probability, do you simplify it always?
When you say simplify, what do you mean simplify?
Like,
Reduce?
Like say you had 14 over 36 and then you simplified it to 7 over
Reduced it?
Yeah.
You don't have to, but
It just makes it easier.
it makes life easier, especially if you're going to have to use that number to get a number later and multiply it. So like if you have to multiply 50 over 100 by something later, better to use 1 over 2 because then your numbers are just going to get massive. Having said that, if it's a little calculation like this, no, it doesn't matter.
Right.
Just leave it. Okay, any questions on that one? Naomi, what do you think? Solid? For sure, for sure?
Yeah.
For sure, for sure, for sure, for sure, for sure, for sure.
Part B too.
There's a part B?
Yeah. It's if it has 5, 7, and the doubles, all doubles.
I didn't understand what you just said. Could
If
you read? Could
it's
you
a
read it?
player-
No, wait. Read it. Yes.
Player A would basically win if
That's not you reading.
Suppose the game is
No. One at a time. No. He had his hand up. Finish.
suppose the game is changed so that player A wins if 5, 7, or doubles, both dice showing the same number are thrown.
Hang on.
5, 7, or both, doubles. 5, 7, or doubles.
Or doubles. Okay, and B wins for everything else.
Yeah.
Yeah.
Okay, so again, we gotta go. So this is part B. Okay. So we see the 5s and we see the 7s, right? And doubles. Well, how many ways can? So hang on. How many 5s were there?
4.
How many 7s were there?
6.
Okay. Doubles means that you have both the same. And you can have double 1, double 2, double 3, double 4, double 5, or double 6, and those are 6 options. And then
16.
now, somebody before said, oh, but you have one die is a 3 and the other one is a 3. Can you switch that? No, it's the same thing. Now, if you have one die is a 3 and one die is a 5, then you can switch it because you can make the first die a 5 and the second die a 3. But when both dice are the same, there's only one way of achieving that. So that's why this is 6, not 12. You understand?
Yeah.
Double 1 is an option, double 2 is an option, ... double 6 is an option. Now your denominator is the same. So we have 12 and 4 is 16 over 36, which is greater than 50%. Therefore, okay, never mind, my math sucks.
18 is the
That's
version.
18 is.
Yeah, I didn't say my arithmetic was any good. Therefore, B still has add. Okay? Questions on that?
Just part C.
Oh, okay.
No, part C doesn't matter. It says design your own one.
Oh, there's no part C.
Okay, next.
So can you explain the next question like this?
Sure.
I wish I had.
Wait a second. The answer is player B has a winning probability of 5 over 9
For which one?
for the B part.
Yeah.
Does that reduce?
Yeah, because that's 8 over 16.
Because
so
it's gonna be-
Oh, yeah, for
It's gonna
B.
be 20 over 36.
Yeah.
Is it?
Yeah.
Yeah, 20 over 36.
A is 16 over 36, right? So B is going to be
20
the
over
complement, which is going to be 20 over 36, which is 10 over 18, which is 5 over 9.
Oh, I made a stupid mistake.
Yes, you did.
You all did.
Why I always make stupid mistakes?
It's fine. It's not. It happens.
Just drop the course.
Oh my god, everyone is so mean.
You guys are all mean to each other.
Gita.
Mira, you're
Gita.
Okay, what's the next one?
326, number 12.
Put up your hand if you want to read it. Don't just read it. Go ahead.
Explain.
Did you understand that question?
Yes. Suppose 4 of the 22 tag bucks are randomly chosen for.
Suppose that what? 4 of the 22 tag bucks?
Yeah,
You say that as if I'm supposed to. It says that as if I'm supposed to know about these.
So I didn't figure it out
4
for like 5 minutes.
out of 22 tagged bucks.
What is
Yeah.
that, sir?
Yeah, I don't.
I think
It's a male deer.
yeah, it's an animal,
It's a
and it's tagged, maybe meaning that they, sometimes when they have animals. When they have animals in nature, they want to keep track of them, so maybe they put a tag on them or something. Okay, so you have Okay, go on. What about 4 of these?
Are randomly chosen for a behavior study. What is the probability that part 1 it says all 4 bucks have the same cross-hatched antlers?
Have they cross
Yeah, I don't.
This is a chapter problem, so you have to check out the chapter.
Yeah.
Okay, so then,
Really?
go back.
Okay.
If all these actually check these
I think it
problems.
had something to do with the
You have
back.
to go to the chapter, the beginning of the chapter. Not-
Really?
I'm telling this guy.
I gotta sit for a second here.
Wow. That's so smart.
So some have cross 6.2, right?
Guys, once we pass this unit, it's gonna be downhill. It's gonna get easier.
So this will 90s, basically.
What?
Basically like 90s
This is gonna be 90s?
after this.
Should be. Should be.
Did anyone find the so no, what page is it?
I want to get a 90 something
301.
part.
I hope you get 100.
Thank you, sir.
48 randomly tagged, 26.
This sounds like a very annoying question, but
Yeah,
you guys have to give me the background, right?
Do you want me to read it, sir, the whole thing?
Okay, go ahead.
Biologists are studying a deer population in a provincial conservation area. The biologists know that many of the bucks, male deer, in the area have an unusual cross-hatched antler structure, which seems to be genetic in origin. Of 48 randomly tagged deer, 26 were chosen. 26
Hang on,
were
48 randomly
tagged
tagged.
deer. 26 were females. 22 were bucks.
Hang on, 26. Or male or bucks. Yeah.
And 7 of the bucks had cross-hatched antlers.
Cross hatch. Yeah. So then I'm assuming the others did not. So what's 22 minus 7? 15?
Yeah.
So 15 do not have cross-hatched antlers. Yeah.
After that, it says several of the does, which is a female deer, have
Several of the what?
does. Apparently, that's the
The
female
dove?
does.
It's those.
Does.
Does. Oh, my bad. I didn't know.
Does. Several of the does, yeah.
Does have small bald patches on their hides. This condition also seems to have some genetic element. Careful long-term study has found that female offspring of does with bald patches have a 65% likelihood of developing the condition themselves, while offspring of healthy does.
Okay, wait. So probability that a female
65.
is got the bald thing
65.
on her own, is 65%. Yeah.
While offspring of healthy does have a 20% likelihood of developing it.
So. It still has to be a female.
Yeah.
So female baby. Say it again, probability that offspring.
While offspring of healthy does have only a 20% likelihood of developing it.
Oh, okay. But this is conditional probability. I have to teach you what that is. You don't know what that is.
Is it like depending event?
Okay, what was that probability?
20%.
20%?
Yeah. And then after that, it says currently 30% of the does have bald patches.
Okay. I.e. not past from mommy. And then probability a female has is bald, right?
Yeah.
Is what?
30%.
Okay. Okay, that's a lot of information. Okay, is that all of the information, the backstory information?
Yeah.
Okay, now we go back to question 12. What was part 1 from question 12?
It said, what is the probability that all 4 bucks have the cross-hatched antlers?
4 random males have the cross hatch.
So it's 7 out of 22.
4 random males. Okay, so what do we have here?
7 over 22.
I'm looking first. Okay. 7 out of the 22? Yeah. So, the probability, yeah, we'll leave it like this. Probability that one male has cross-hatching is 7 out of 22. Agreed? Now we need to know the probability that all 4 males, okay, have the cross-hatching. So I would say that the probability that 4 random males have cross-hatching is actually, I say it's 7 over 22 to the power of 4. Who agrees with that? Which is going to be a hell of a lot smaller than 7 over 22. Does it make sense that it's smaller?
Yeah.
Sure it does, because let's say the first one is got the cross-hatching. Is it a guarantee that the next one will have it?
No.
No. Is it a guarantee that the next one? So you could have here, if you have 4 deer, 1, 2, 3, 4. You can have a yes, no, 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 right? Then you could have a yes, a no, a yes, a no, a yes, no, yes, no, right? And so on and so forth. The only successful path here is going to be 1, 2, 3, 4 yeses, right? And the probability of each yes is 7 out of 22. So it's 7 out of 22 times 7 out of 22 times 7 out of 22 times 7 out of 22. Now I taught you, you could do it in terms of, you could think of it as 7 to the 4 divided by 22 to the 4, where your numerator is the total number of ways, right? But I told you that you can multiply probabilities for events that can exist simultaneously, right? So if one deer is cross-hatched, can another deer be cross-hatched? Yeah. If one is cross-hatched, another could be cross-hatched, right? So, no, whoa, actually, wait, whoa. This is true, but it's not completely true what I'm saying.
Wouldn't this be like
This is true, but it's not completely true. This is actually only an approximation. And it's based on a big assumption. Let's see if you guys catch what I'm about to say. Assuming deer, whatever. Male deer pop is very large.
Yeah.
Do you guys understand why?
Yeah, because if it's that low, then it will have to be, the rest would have to be 7 out of
What's the probability of drawing an ace out of a standard deck of cards? 4 out of 52. If you draw an ace, what's your probability of getting an ace again? 3 out of 52. If you didn't, sorry, 3 out of 51. If you didn't draw an ace, what's your probability? 4 out of 51. So in actual fact, once one has been selected, right, the probability of another one being selected changes. So it's actually a conditional probability there, right?
I'm pretty sure that's.
But the problem is, they don't give you the entire population, right?
They said that's how many they chosen. So
Yeah, but that's 48 randomly tagged deer, right? They don't mean out of 48. They mean out of the, I'm assuming they mean, what's the question say?
It's like a randomly
They mean from the entire deer population, right? If they mean if they mean out of
No, 48.
If they mean out of 48, okay, then obviously it's going to be
7 out of 48.
7 over 22 multiplied by 7 over 21.
yeah. You'd have,
7 over 21?
you'd have to go 7. You could do 7. You could do it one way. You can do it is just 7p. How many do we want? 4 over 22p4, right? Because this is going to be 7 by 6 by 5. See, what he just said is this. I just write it this way because it's easier, right? Because 7 over 22 times 7 times 6 over 21 times 5 over 20 is the same thing as 7 times 6 times 5 times 4, which is 7p4 over 22p4. Now, check the answer in the back of the book. Calculate this percentage and check it. If they mean out of the 48, then I agree with you. It's going to be 7p4 over 22p4, which is just 7 over 22 times 6 over 21 times 5 over 20 times 4 over 19. But I have a feeling what they mean is against the entire population.
1 over 209.
What's their answer?
1 over 209.
Which is what percentage?
Well, that's a small one.
You guys need a calculator. What's
It's 4.78 multiplied by 10 to the degree of -3.
That's not a percentage though, right?
It's
So 0.47.
That's just this divided by this, yes? That's just this divided by this. Okay, calculate, give me this. Put this in your calculator, tell me what this is.
This or that? The people.
Give me this.
sure, that one is 47%, 0.8. 47%.
What are you talking about?
How can I do
What?
this?
That's impossible.
How's that 47?
You can't, that's gonna have 2 zeros. This is equal to 0.00478. If you wanna do it as a percentage, it's just 0.478%. I don't need it as a percentage. That's fine. When you did this over this, you got this, right?
Yeah.
Okay, now just do this over this and raise it to the 4. Don't give it to me as a percentage, just give me a number.
Give a number?
Okay, somebody else. Just calculate this.
0.0102.
That was math.
Now calculate this.
Wow. That's
7p4 over
22.
22p4.
It's 4.78 multiplied by. Yeah.
Told you, sir. Told you.
Okay, so when they ask this question, what they're asking is in reference to the 48. And obviously 48 is not a huge number. So if you're talking about relative to 48, every time that you actually pull out a male deer, right, then you're having a significant impact on the probability of the next one being a male. So this one only applies to that. So this is the solution that they're going for. Any questions on this? On why the answer is 7p4 over 22p4? Do you understand that? Okay, so that's what they were going for there. Okay. Let me come over here. Okay, was that a part 1 or was it a part A?
That was part one.
A part 1.
Okay. Naomi, are you clear on this so far? You can see why the numbers went down each time? Because it's like you're plucking a card away out of a total. Okay, what's part 2?
At least one buck has crosshatched antlers. Probability of that.
I would do indirect here. Okay. At least one. Better to just go 100% minus none, right? So, and does it say, are you grabbing 4 or anything like that, or
Yeah,
no?
it's the same thing.
Does it say that?
Yeah, because it says in the beginning, A suppose 4 of it.
Oh, okay. So, before we did 4 and a. So, quiet. At least one 1 out of 4, and then probability 0 out of 4, right? So probability that one male is not crosshatched, or I could write it like this, crosshatched prime, is going to be the complement of 7 over 22, which is 15 over 22. Okay. And now, so that means that one male is not crosshatched, right? So if we, this is our little aside here. So if we continue now with that, to bring that down here, we're going to have 1 minus 15, pick 4, order counts, 22, pick 4. Does that make sense? Because that's 15 over 22 times 14 over 21 times 13 over 20 times 12 over 19, right? And each time you pick one that is not cross-hatched, you have one less that is not cross-hatched, and each time you pick one out of the total, there is one less. Okay, so what does that give you? Anybody? Next. Any, I gotta sit for a sec just because of my ankle. Any questions on that one?
So that's indirect, right?
That's indirect, for sure. If you wanted, you could have calculated the probability that 1 out of the 4 had the cross-hatching, 2 out of the 4 had the cross-hatching, 3 out of the 4 had the cross-hatching, 4 out of the 4 had the cross-hatching, and added all of those up. But it's a lot faster to just go 100% minus the probability of failure if calculating the probability of failure is an easier calculation than calculating the probability of success. Does that make sense?
No crosshatch. 1 minus no crosshatch equals to at least 1 crosshatch.
This number here, okay, you guys see? Is this. Naomi, what do you think? No? Completely? So where does it fall apart for you? So should I do it from the beginning? Huh? Okay. So you're taking 4, and you want to know the chances that at least 1 out of the 4 male deer that you choose have this crosshatch pattern. So that means I could figure out the probability that exactly 1 out of the 4 have it, 2, 3, and 4, and I could add all those up. If 1 out of 4 have it, that's different than 2 out of 4 having it, which is different than 3 out of 4 having it, which is different than 4 out of 4. So those are mutually exclusive events. You add the probabilities. But wouldn't it be easier to just figure out the probability? If the objective for success is 1 or more out of 4 having it, then the failure would be if none of them had it, right? If you added the probability of none of them having it, 1 of them having it, 2 of them having it, 3 of them having it, 4 of them having it, you get 100%. That's all total possibilities. Okay? So better to just go 100% minus the probability of failure, right? See, if you define a system as having success or failure, that means it's a binomial system. There are 2 options. So if you define a system as only being successful or failure, then 100% minus probability of failure equals probability of success, right? Or conversely, 100% minus probability of success equals probability of failure. So this is going to be probability of failure. And this is probability of success. Probability of success is annoying to calculate. I gotta go probability of 1 out of 4, 2 out of 4, 3 out of 4, 4 out of 4, add them up. But probability of failure is just one thing, meaning that none of the... Does that help a little bit more? You got it now?
Where'd you get it from?
Okay. Next. It's a good question. Next.
How come we inject order? Like, how come we don't use,
Why do you inject order? I mean, the truth of the matter is, in this question, you could have done it with combinations, okay? Because you could have imagined yourself grabbing
That's exactly what you're saying.
4 at the exact same time, but will it make a difference? No, because if you do it with combinations, you're just going to have an offset of the R factorial anyways.
Either fail or success.
So it doesn't matter. The reason why I did it with order, because in my mind I visualized taking one and then taking another and taking a third and a fourth. But if you took them all at the same time and did combinations, you'll get the exact same answer.
Alright. No, would we have to state, like...
No, you wouldn't have to state anything,
Alright.
because I'll see it in your math. You would use the C, right? You go 15C4 for 22C4.
Yeah.
You'll get the same thing.
Okay, awesome.
Yeah, physically that would mean that you literally went into the bag or into, you were God and you went down into the pen and you, or into the forest and you grabbed 4 at once, right? In my case, I'm picturing myself bringing 1 in and a second, a third, and a fourth, or picking a card one at a time. But I've proven to you that it doesn't matter in those cases. Next. Part
There's
3.
only 5 minutes.
What's next?
There's no C.
You've done A1 and A2.
There is a B.
Is there an A3?
It's a B. There's a B.
What's B, Ken?
The B is if 2 of the 7 cross-hatched males are randomly selected for a health study. What
Okay.
is
So 2
of the
males that are cross-hatched, yeah?
2 of the 7 cross-hatched
Yeah.
randomly selected? It's like combination, and then the
No,
probability.
I'm not asking you to interject your.
Oh,
I just want you to
sorry.
read the question.
And then what is the probability that the eldest of the 7 will be selected first?
If 2 out of the 7 cross-hatched males are randomly selected for a study,
Yeah.
then what?
What is the probability that the eldest of the 7 will be selected first, followed by the second eldest? Okay.
Yeah. This sounds to me just like that question you asked yesterday, Ken. So you have a 1 in 7 chance, right? That the eldest will be selected, right? Agreed? When you choose the first, you have 7 cross-hatched males, right? And there's only 1 that's the oldest. So you have a 1 in 7 chance that the oldest is chosen first. And then you have a 1 in 6 chance that the second oldest is chosen, is next, right? So I say the answer is 1 out of 42. Questions on that?
That's it.
That's it.
I think so.
Can we do 7P2? I mean,
Yeah, it's the same.
Yeah, obviously.
7P2.
Oh, come on, give me a break. It's, yeah, sure, it's 1 over 7P2. Yeah, I can
Yeah.
see that too.
Drop the course.
I mean, give me a break. Okay, is this B part 1 or is this part 2?
Finish.
Next part?
Finish.
We're done with this question?
Yeah.
What about all the other information? What about all this?
It's for another
It's
question.
useless.
It's not useless. We're gonna have to
That's
use-
for another communication question.
Yeah, we'll deal with that later. This is very important stuff. We have to talk about conditional probability afterwards. Okay, so that's enough for today then?
Yes.
That's the-